Hello everyone, I think this is working. Today we're going to talk about, I notice I touch my ear a lot when I'm streaming. What is that? It's like a nervous tick. I'm stressed, so I'm touching my ear. I'm Vulcan or something. Um, we're going to be learning some Gleam, so that should be fun. Oh, it's pretty cold here. Let's see. Wow, there's already somebody on Twitch. Hello and welcome. We're going to be learning some Gleam today. So I'm just getting started here. I don't think there's anyone on YouTube yet. Oh, there is. Hello, hello. I should try to put chat on the screen. How is everyone? You can kind of like, don't mind me too much while I just get started here. Gleam, in case you don't know, is a functional language. And it's something that I always was really interested in. So I wanted to see, but then I went to like this meetup and they were just so nice and they were so excited about the language. So I'm like, okay, let's check it out. All right, let me see if I can get YouTube in here. YouTube chat. Oh, I'm like not really in line here. Let's do that. YouTube chat properties. I think this is, yeah, this is supposed to be right. Now I should be able to take my YouTube URL, do this, and did it work? I don't like you see it, but I can't really, it doesn't say anything. Well, let's leave it on here. Maybe it will show something when someone types something. We'll see what happens. Okay. So we have the Gleam page up. So what happened? How did I get excited about Gleam? So I do Elixir programming. And, you know, that's built, that came from the Beam virtual machine, which is like Erlang was first developed. That was like the Ericsson phone company. And they wanted something that could really scale out. And so they made a language and a virtual machine called Beam is the virtual machine. But Erlang's like this kind of like old style syntax and it's not very friendly to people. It actually like looks a lot like Prolog. So it's a declarative sort of language. And then like they made Elixir, which is also on top of Beam. Like there's other Beam languages, but Elixir really like became popular. It kind of came from Ruby, and yeah, so that was built, and it was like really scalable. Had Ruby kind of syntax, was very easy to use, and a lot more friendly. So it has like a lot more modern in terms of syntax. And so like that's what happened. Big developments on Beam. And it really like has really great concurrency. So if you got lots of like, if you got something like a web server and you need a lot of things running at the same time, oh, hello. Yeah, I was checking, thank you. I don't know why I don't see the chat show up here. Oh, maybe I have to do this. Oh, it does work. Great. I have chat working again. Awesome. From Lithuania. I've never been there. I'm in France, not too far from Lithuania. So I want to do more Rust. It was like when I got on today, I was like, I was really a toss up because I have this like list of languages, right? It's Haskell we did one on. I've been doing a lot on assembly language programming on 8-bit computers just because I'm a little bit hyper fixated on it right now. I have COBOL I'm playing with, Nix, which I've done a lot of recently. I did one Rust, and now I'm doing Gleam. But like right before starting this, I was like, do I do Gleam or do I do Rust? And it was really a toss up. But I just went to a meetup and there were some people there who were just like so cool. And they were so excited by Gleam that I just wanted to try it out, just do it like um, a little tour of Gleam to see what it's like. It's supposed to be very easy. But I was just explaining that it's based on the same VM as Elixir, except that it's statically typed. So like everything has types. And that's one of the things that's a little difficult with Elixir is that like it's dynamically typed, but it does have a lot of facility to, with guards and stuff, you can really kind of check like what you're getting in as parameters. You can say like, I'm getting this parameter, but only if it's an integer or whatever, right? And then you have another thing called dialyzer, which does type analysis on your program and checks like, oh, you think over here because you kind of give it like little hints, and it's like, oh, over here you're saying you think you're getting this, but you're actually getting this because I looked at what is calling you. And so it kind of does type analysis that way, which is kind of nice, except dialyzer is really, it's not the easiest thing to read in terms of error messages. So I was always excited about like, the idea of Elixir with better types. Elixir is working on types, adding like gradual typing to Elixir, but it's going to take a while. Gleam is already here. The community is just awesome. And look at their logo. It's like this happy star. Like, so I was talking to someone earlier and they were like, what were they saying? They were saying like, oh, they chose Go as their favorite language because of the mascot. It has that gopher. And for real, that gopher is really cute. So I don't blame him. And Gleam is really cute also. And if you go on their Discord side, it's like they're the nicest people too. So I think it's great. So we're going to take a quick look at it. I don't have it like installed right now. So this is the crossover to my Nix series because I want to see if we can actually use Nix to install Gleam. I went on to nixos.org to like search packages. I typed in Gleam and I see the first result is Gleam statically typed language. I don't think any of these are better. So I think I'm going to just try to install Gleam and we'll see what happens. So we'll go into projects, we'll make a Gleam directory. And now we're inside of Gleam. More Nix videos. Thank you. Do you do Nix also? Sorry, how do I look at your name here? It doesn't tell me. Damn it. I'm like such a streaming noob. Anyway, so, and now we will make a, let's just try Nix shell and pass in Gleam and see if this does what we hope it will do and download Gleam and install it. And then we'll say like, oh my God, Gleam, Nix is so awesome. So maybe we have Gleam now. Look at that. We have a Gleam. But if you're not using Nix at home, don't worry. I'm sure this explains how to install Gleam. So let's go try Gleam. Is this where we want to go? Welcome to the Gleam language tour. So we'll just start here. The tour covers all aspects of the Gleam language, and assuming you have some prior programming experience, should teach you everything you need to write real programs in Gleam. Well, that's very promising. Look, they're happy too. Do you see how like the tour is interactive? It's like exclamation point. The code shown is editable and will be compiled and evaluated as you type. So I'm not going to need my editor, I don't think. Oh, this is cool. except that you guys can't see stuff well. So let me change this a little bit. I think I can just move this over here because I don't think I'll need my editor much, right? And then we have this big space here. What do we do with this? Maybe you just want to see me? There we go. Vim best. I don't know. Maybe we'll try it like this. No idea. Where were we? Okay. Editable and compiled as you type. Anything you print using io.println or io.debug will be shown in the bottom section. I think they're talking about here. Can you guys read this? I should make this bigger, no? No, it's kind of ugly like this. Damn it. Ah, well, you'll just have to make do. Along with any compile errors and warnings. To evaluate Gleam code, the tour compiles Gleam to JavaScript and runs it, all entirely within your browser window. If at any point you get stuck or have a question, do not hesitate to ask Gleam Discord server. We're here to help, and if you find something confusing, then it's likely others will too, and will want to know about it so we can improve the tour. Look how nice they are. This is like, I think this could be like a B language, and I would still use it just because, like, these guys are so nice, right? Bigger, better. Well, I don't know how to make this bigger, better. I guess it like shows here. I don't know how to do this. Yeah, I don't think we'll be able to see it otherwise, unfortunately. Sorry about that. Let's see. Let me pop out Twitch chat also just in case someone says anything here. Okay. Where are we? Okay, let's go. Click next to get started. Click contents to jump to a specific topic, or go here to read everything in one page. Oh, maybe that's better. Let's see if that helps. Hey, where's our... Let's see if this changes anything. Maybe that's easier to read. Let's see what happens. Basics. Hello world. There is a tiny program that prints out the text, Hello Joe. Oh, we're not like quite normal here. We're being different. We'll explain how it works shortly. In a normal Gleam project, this program would be run using the command Gleam run on the command line. But here in this tour, the program is compiled and run inside your web browser, allowing you to try Gleam without installing anything on your computer. Try changing the text to be printed to Hello Mike and see what happens. Let's just try. Can I click run? So it says Hello Joe here. Do you guys see that? And then I'm going to change this to Mike. Oh, and then it updated it like on the fly. That's pretty cool, isn't it? I wonder what Gleam people are called. Do you think they're called Gleamers? Hello, Gleamers. There we go. You see that on the bottom here, right? All right, let's keep going. Boom, boom. Oh, your name's A. That's why. You just confused me because I thought the A was part of what you were writing. Boom, boom. Are you French? Gleam code is organized into units called modules. A module is a bunch of definitions of types, functions, etc. that seem to belong together. For example, the Gleam/IO module contains a variety of functions for printing, like println. All Gleam code is in some module or another, whose name comes from the name of the file it's in. For example, Gleam/IO is a file called io.gleam in a directory called Gleam. Okay, that's a lot of stuff, but I think it'll just make sense when we actually use it. You're learning Nix. Cool, cool. For code in one module to access code in another module, we import it using the import keyword, and the name used to refer to it is the last part of the module name. For example, the Gleam IO module is referred to as IO once imported. Okay, got it. That's pretty clean. The as keyword can be used to refer to a module by a different name. See how the Gleam string module is referred to as text here. So we changed it to text here. So, and then we type in text.reverse. Hello, Joe. So on the bottom, you see it's reversed. It says, Ioj ole. Ioj ole. What language is that? Doesn't it sound a little bit like Italian? Ioj ole. Nani? Nani nani? Nani desu ka? So, I assume here then if we got rid of this, then this, what would it? It's gonna say it's gonna fail. But then we can change this to io.reverse, right? If we understand, no, string.reverse, and that works. But if we change this to as, and we call it something like, what's like strings, like word stuff, right? Then we just have to do word stuff here, and then it works again. So, you know, good to check that we actually understand what's going on. Hey, Cesar, good to see you again. Sounds like French to me. I think it's only because I start saying it in French. Iojole? C'est ça. C'est bien cela. All right, let's keep going. Unqualified imports. Normally, functions from other modules are used in a qualified fashion. This is like story time for you all, isn't it? It's like I'm reading. It's like when you were a kid and then your parents read you like a book, except we're reading programming books, right? Tu me regardes? Meaning the name to use to refer the module goes before the function name with a dot between them. For example, io.println hello. Can women program? I heard that's possible. I heard it's possible. It is also possible to specify a list of functions to import from a module in an unqualified fashion, meaning the function name can be used without the module qualifier, the name and the dot before it. Generally, it is best to use qualified imports as this makes it clear where the function is defined, making the code easier to read. So here we have import the module and one of its functions. So now we have, I see, you're able to do this. So io.println, this is qualified, println, this is unqualified. So if I do import, what was it called? Strings? Strings? io.strings maybe? Oh, gleam.strings. Let's go back and see what it was called. Gleam/string. Import gleam/string. Import gleam/string. Here we go. And now we use something like println string.reverse. And we passed in this thing, right? So here it's reversed, but it's saying I should be able to use this without a qualifier. Interestingly, it doesn't know what the scope is. Maybe what we need to do is actually put in reverse here, is what it means. So here we go. Yeah, so that worked, right? So now I can do string.reverse here, and it worked. Or I can just do reverse. But it doesn't work if I just do string. And now we're going to, I think that covers this. Nothing really else to test, right? Type checking. Gleam has a robust static type system that helps you as you write and edit code, catching mistakes and showing you where to make changes. Uncomment the line IO print line 4 and see how a compile time error is reported, as the IO print line function only works with strings, not ints. So, yeah, so we're not allowed to do print line and a number here. So let's uncomment this. We see over here my lucky number is, that's coming from here, and then now we're trying to print something else. And it says here, print line 4, type mismatch, print line 4, expected type string, found type int. This is a really nice, I think this is a really great error message. It tells you right up front, type didn't match. It tells you where. It puts the context in here so that you see what line it is, and it tells you exactly where. Like sometimes compilers try to do this, but then it points somewhere that seems totally ridiculous. So that's not very good, you know? And then it says expected type string for found type int, right? So it wants a string and made that part clear. So if we did this, it probably will work. And there it goes, right? My lucky number is 4. To fix the code, change the code to call io.debug function instead, as it will print a value of any kind. So the debug function will print anything out. All right, so that means I can call the io.debug function, io.debug. I wonder if they mean to do it like this. No, they don't mean this. They mean like this then. There we go. My lucky number is 4. And it's debugging. Although that kind of feels like cheating, because debug and printing out is not the same thing. Documentation better would be nice. What do you mean by that? I think this documentation is really good. And they say uncomment this line. Very nice, very clear. Gleam has no null, no implicit conversions, no exceptions, and always performs full type checking. If the code compiles, you can be reasonably confident that it does not have any inconsistencies that may cause bugs or crashes. So that's pretty good. Too bad this thing doesn't return the number 4 so that I could put it in here. All right, let's keep going. Ints. Gleam's int type represents whole numbers. There are arithmetic and comparison operators for ints, as well as equality operator, which works on all types. When running on the Erlang virtual machine, ints have no maximum and minimum size. So ints can be like as big as we want. When running on JavaScript runtimes, ints are represented using JavaScript 64-bit floating point numbers. So this is kind of an interesting thing. Like basically, my understanding is that Gleam will compile into either for Beam and run it on the Beam virtual machine, or it can compile into JavaScript. And what that lets you do is basically use Gleam both on the server side and also on the client side. So it's a little bit like Node for the back end and JavaScript for the front end. And you have just like one thing. The only weird part is if they don't act the same, then it can get a little confusing. Like if you have a lot of things like this where it's like if it's on this machine it does this and if it's on this it does that, that can get a little confusing. But so far being limited to 64 bits is not bad. So I think we're okay. The Gleam int standard library module contains functions for working with ints. So here we have a whole bunch of things. We have addition, subtraction, division. So let's look at this division thing. So this was 2, obviously. This is the 4. And here it's doing integer-based math. So it loses precision. And this is in line with what they said earlier, where it does no conversion, right? It doesn't try to be like, oh, you're dividing two things, I'm going to turn them to floating point numbers. It doesn't do that. 3 times 3 is the 9. And the percent must be the modulo operator, the remainder operator. So it's 5 divided by 2, and then you have a remainder of 1. Now we have comparisons here. Looks very standard. Equality makes sense. And looks like their Boolean values are capital true, capital false. And then we have functions like max and clamp. All right, sounds good. I don't think there's anything for us to really try here. Gleam's float type represents numbers that are not integers. Gleam's numerical operators are not overloaded. So there are dedicated operators for working with floats. Gleam's numerical operators are not overloaded, so there are dedicated operators. I see. So the plus and all of that stuff, it's never like, oh, this is the plus between two integers. This is the plus between for two floats. If you see plus, it's integer. If you see multiply, it's integer. And floats will have a different operator. Floats are represented as 64-bit floating point numbers on both the Erlang and JavaScript runtimes. The floating point behavior is native to their respective runtimes. I see. So their exact behavior will be slightly different on the two runtimes, which I guess means that how they actually do the math with the floating point numbers might be slightly different, which is a little funny because I thought those were like IEEE standards, but perhaps not. Under the JavaScript runtime, exceeding the maximum or minimum representable value for a floating point number will result in infinity or negative infinity. Should you try to divide two infinities, you will get not a number as a result, and it's NaN. Do we see that here? How come we don't see that here? All right. This, I'm guessing, is running on the JavaScript runtime, right? Because it's probably running in the browser. When running on the beam, any overflow will raise an error, so there is no not a number or infinity float value in the Erlang runtime. Raise an error. Didn't they say earlier that they don't have any, like, let me try to find that. Didn't they say earlier that it has no exceptions? I thought it did. Type checking. Uncommented code to fix code. Gleam has no null, no implicit, no exceptions. So here it says there's no exceptions, but then when we look at floats, it says it will raise an error. So maybe raising an error and an exception are two different things, but as far as I thought, they were basically the same thing. So we'll see what that means. So there is no not a number or infinity float value for in the Erlang runtime. It's interesting they don't say Beam, they just call it Erlang runtime. Division by 0 will not overflow, but is instead defined to be 0. Oh, wow. Here, this one. Divide by 0, I see gives you 0 right here. Interesting. That's, I guess that's interesting. But then in, I just wonder, like, in IO for integers, what happens when you divide by 0? Oh, you also get 0. Okay, good to know. So let's see what they've done here. We just add a dot to all the operators. Equality works for any type. So this operator is overloaded, I think, right? Because it works for floats and it works for integers. Anyway, so plus will add, minus will subtract, divide, multiply, greater than, less than, equal to or greater than, less than or equal to, divide by 0, and then we have max and ceiling. So I guess my question was, what happens when you exceed infinity, right? Let's see. Do you think we can exceed infinity? Let's do like some big number. This is definitely something it could print, right? Let's put it on the top so it's easier to see. All right. And then we'll just like, I guess multiply by the same number. Oh, now it says it's using scientific notation to print that out. Ah, infinity. Here we go. It turned to infinity. All right, they didn't lie. It goes to infinity. You don't need to comment on how I look. We're here to learn. I think that's everything on this page. Number formats. All right, next subject. Underscores can be added to numbers for clarity. For example, whatever number this is, I have a, like, my eyes get crossed. This is 1 million. Can be tricky to read quickly, while 1 underscore 3 zeros underscore 3 zeros can be easier. Ints can be written in binary, octal, or hexadecimal format using 0b, 0o, and 0x prefixes respectively. Floats can be written in a scientific notation. We saw that earlier, right? So that's pretty cool. Yeah, the underscore is pretty popular in a lot of languages. I definitely noticed this in Rust. And here is some binary numbers, octal numbers, hexadecimal numbers. And then, you keep doing that, I'm going to have to kick you. Scientific notation, float literals. I think this is all pretty easy to understand. This number is 1, 2. This is 1. So this would be the zeros place. This would be 2, 4, 8. So this is like 15 here, right? Yeah, 15. Gleam has the equal, equal, and not equal operators for checking equality. The operators can be used with values of any type. Look at that. They said that the operators were not overloaded, and it looks like they are. They're admitting it. But both sides of the operator must be of the same type. Equality is checked structurally, meaning that two values are equal if they have the same structure rather than if they are at the same memory location. So if you make two strings and it's hard to say how Gleam does it, but it doesn't care where it is in memory. That makes sense. Right, so we can make strings here. Foo is equal to foo. And that's true, but foo is not equal to food. We learned about ints, we learned about floating point numbers, and we learned about, so obviously if I put underscores here, oh, it can't have two underscores, but it can have one underscore. I wonder if it can have an underscore. Nope, not in the beginning. It has to be between numbers. So those two numbers are the same. Strings. Here we go with strings. In Gleam, strings are written as text surrounded by double quotes and can span multiple lines and contain Unicode characters. Oh, that's really cool. Usually you need a different kind of like token for multi-line strings. We've been doing nicks, and that's like two single quotes in a row. The less than greater than operator can be used to concatenate strings. I think that's the same thing we have in Elixir, if I'm not mistaken. I just forget my languages sometime. Where are we? Is this it? So with Elixir, foo bar. Yeah, so it's the same operator to concatenate two different strings. Several escape sequences are supported. Double quote. Okay, so if I need to have a double quote, I add a backslash itself, form feed, new line, carriage return, tab, and Unicode code point. Who knows the difference between carriage return and new line? I know one of them is ASCII 13, right? I don't know what the other one is. Where is this? 13 is carriage return. I don't know which one is new line. I don't scan things very well. Doesn't matter. I think carriage return used to mean like in those physical, they used to have like those mechanical printers and teletypes. That command would just tell it to like go back to the front and not necessarily advance the feed. So I think that was a difference. But for me now, I think most of the time we use just new line. The Gleam string standard library module contains functions for working with strings. So here we go. Look at all these cool strings. We have some Japanese stuff here. Konnichiwa. Konnichiwa Gleam. Look at my Japanese skills. Here's a multi-line string. Here is a Unicode character. See, so it says multi-line string here. So it adds this several spaces over here. You can see that here. Hello, Eric. Good to see you. Gleam is amazing. So far, it's like super straightforward. Like really good trade-offs. The operators are mostly not there's no overriding operators. The types make a lot of sense. They're simple. I like how this multi-line thing is one thing. I think one, just the double quotes for both multi-line too. X marks the spot. So here we see that it's trying to add the double quote, so it needs to escape the double quotes with a backslash quotation mark. And now here we're concatenating two strings with this, and we've already seen reverse, and we have not seen append. Append's a funny one, right? Because like basically A, B, C, D, E, F is the same as just doing A, B, C, D, E, F, right? But maybe append is, I don't really know why you would use append instead, but maybe there's a reason. What else did we learn? We learned how to like change this name, string, right? So we can do string. What was it like? Was it this syntax, reverse, I think? And now I can just type in reverse. Look at that. We learned that. And we also learned to name this as something else. So we can just do, this won't work. We have to do foo.reverse and it works. I just like to retry things that I've learned previously. Let's look for a star Unicode character. How do I look this up? Alt codes maybe? Is this the Unicode 2606? Let's see. 1F. I don't think that's how it works, huh? Well, maybe I shouldn't do this. I was hoping to just like copy a Unicode thing, but I don't actually know what these Unicode characters, how this works. Here, 1F600, 1F600, grinning face. And he's a grinning face. So if I look for star here, so I just copy what's after the plus. What looks like a Gleam star? There's a lot of stars. Maybe this one? So I think if I copy this into here, hey, look at that, it worked, right? Almost Gleam star. There we go. Hey there. Yes, I see you, Arts by Natalie. Good to see you. Let me add that. Let me add Twitch chat also because it's not fair. Na, 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 na. All right, not the prettiest thing in the world, but we'll make it work. All right, let's see you later. What do we do? Remove? Oh, that just removes one person. All right, maybe that works. What does it say? I think the only thing I miss in Gleam is type classes traits. So you can't do something generic over behavior. Oh, is that true? Yeah, Rust has traits. Elixir has like protocols, a lot of stuff you can do. What are you making? Arts by Natalie. We're learning Gleam. I went to a Gleam meetup here in Paris and it was really fun. And the guys there just love the language so much. So I wanted to check it out. I already use Elixir, which is on the same virtual machine. So it's kind of like staying in the same family, you know? So I'm figuring it can't be too hard to learn. A bool is either true or false. Yeah, it makes a lot of sense. These are the operators, what you'd expect. They are short circuiting, makes sense. So when you have like, that's a common thing you do. Like if you don't want to evaluate the rest, you can just start with something and something else. And if the left is false, then obviously it doesn't need to evaluate the rest because and can only be true if everything is true, right? Um, and the same with or. If the first thing's true, it doesn't need to evaluate everything else. The Gleam Bool standard library module contains functions for working with bools. So we have true and true, true and false, false or false, false and true. Exactly. So we have true and false is obviously false. True and true is true. False or false. This should be here. False or false is false, and false or true is true. And we call bool to string. True, it turns it into the string true. Bool to int. False is 0. So I'm guessing that true is going to be 1. Yeah, so they use false gets the short end of the stick all the time. It gets to be 0. And true gets to be 1. I love to watch coding stream, but I am too bad at it. Huh. Well, yeah, this is going to be a VOD on YouTube also. And in general, like when it gets harder or whatever, we're gonna be doing it together. So if you try to do it on your own, because I'm just using the standard language tour, if you're doing this and you run into any problems, you just kind of like find where I'm at and see how we do it. You know, it should be. That's my hope with this kind of content is that like I'm not teaching you because I don't know it, right? But like I'm learning it too. So if we learn it together, if something's not clear, then hopefully you see how I interpret what they're saying. And that's helpful. And also I have a Discord server that's in all the YouTube videos that you can join if you ever have any questions. So if you say like, oh, I'm just not good enough for this, I don't know what's going on, then like, let's just get on and chat about it on Discord. A NAND gate would be not and. Yeah, wouldn't it be the first one? A value can be assigned to a variable using let. Variable names can be reused later by later let bindings. Variable names can be reused later by let bindings. Okay, so basically you can reuse a name that you have before, but the values they reference are immutable, so the values themselves are not changed or mutated in any way. In Gleam, variable and function names are written in snake case. All right, that makes sense. Do you think about having custom stuff for your channel? Can you explain what you mean by that? I'm always interested by what that could mean. Where are we? So we have let x. I wonder if I can like, no, it's all right. So we have let x equals original and then we print it out. So it says original here. Assign y to the value of x. So now y should also be original. So it'll say original again here. assign x to a new value. So now this x is going to point, or it's going to basically be assigned to new now. So the third thing it prints is going to be new. And then y is still referring to the original value, so it says original. Yeah, that makes sense. I don't really have much to do, but I think like these guys are doing so much of the work for us that I think we should just like try stuff here. Like let x equals true and then do io.debug, because I really think unless you get the muscles going, you won't really remember. And this is just doing so much of the work for me, right? So here it's printing true. And remember we had something that was like toInt, right? It was like bool.toInt. I think it was this. Uh-oh. Let's go back and look. Gleam bool. Import Gleam bool. And now I can make this true. And then we had bool dot toString, I think. True. Here it is. It made it to true. And then I can do toInt, and that would make it to the number. Oh, x is equal to true, toInt x. That doesn't make sense. This is not what I expected. Oh, because it's not bool? Bool dot to_int false. Okay, what am I doing wrong here? It was import Gleam / bool, right? And it was like bool dot toInt true. Oh, are you saying that I need to add a debug to this? I'm just like not copying it right. Yeah, I need to add a io.debug here, right? That's what I think that's what it is, but I'm a little unsatisfied with this error message, you know? So bool dot toInt true. So this is going to return a number. And now it says, wait, there's no bool, so I'm going to import it. And now it says it's never used. Probably because maybe it optimizes this out because nothing ever is done with this. But once I do io.debug, now it says 1. That's the difference. It's kind of interesting, right? Like, let's see what you say. Doesn't toInt return an integer value? Yes. And you are not binding it to any variable. Here, yeah, but I had this earlier. I think it was like, let x equals true, and then toInt x. And that works now. I think the problem is I had this code earlier, and it says, this imported module is never used, and it's like, you can safely remove it. No, you can't really, because look, Gleam.io is not used, sure. Now what? It just doesn't think anything happens here anymore, right? But yeah, that's because nothing is really happening. We need to actually print it out using io.debug, and now we have 1. Let bindings, we can use it. I think we understand that. Snake case variables, so it can be xvar, kind of like this if we had such a thing. Did you read my messages? I mean, like having a custom banner and logo, because this is basic need for every streamer. Yes. Sorry, Art by Natalie. Sometimes I miss messages. I really apologize. Um, I really need to do that. I just like some people make videos because they want to succeed or get like views. I just want to make the videos. Like I just want to do this even if it's one person because like or if it's even if it's nobody because I'm still learning it, you know? And since it's going to be stored, maybe someday someone will find it useful. Can I help you with that? Maybe. Let me know. Send me a message. Discard patterns. If a variable is assigned but not used, then Gleam will emit a warning. If a variable is intended to not be used, then the name can be prefixed with an underscore silencing that warning. To change the variable name to score, to change the variable name to score to see the warning. So we have a variable here, we're not using it, right? So I get rid of this and it's like, hey, this variable is never used. So like I could print it out, right? We had this IO print line score, and this would fail, right? Because, oh, it's not IO print line? Yeah. We have to import Gleam IO. And it says it's the wrong type, right? We can almost imagine, was it Gleam strings, was it? Strings or strings? It's string. And remember we saw a bool to string. Maybe there's a, oh no, maybe it's int? Do you think there's an int? And let's see, can I do int dot to string? I can get rid of string, yes. Hey, look at that. It's actually pretty consistent because it had a bool to string. So obviously int dot to string would make sense too, right? So that's pretty cool. Arts by Natalie, like, this isn't something I want to talk about during the stream. Thank you though. So where are we? I think we covered this. Oh, right. But their point was don't, if you're really not going to use it, then you can put an underscore here and that message should go away. Oops. Let's get rid of this import too. And this. We don't need any of this. So if I have it here, it says score is not used. And if I add the underscore, then it's fine with it. And this is like useful when I'm programming. This is how Elixir handles it too, is sometimes you have it and you want to make it clear that that's the parameter being passed in, but you're not actually using it in the function. So you can put an underscore in there. Oh, and Rust does this also. So it's something that is just easy for people. It's something that they've seen before. Type annotations. Let assignments can be written with a type annotation after the name. Type annotations may be useful for documentation purposes, but they do not change how Gleam type checks the code beyond ensuring that the annotation is correct. This is useful because you're going to put an annotation in there because it's what you think it is, right? And then like when you type it in, it's an extra way for the compiler to tell you, yeah, that's what it is, so you got it right. Typically, Gleam code will not have type annotations for assignments. Try changing a type annotation to something incorrect to see the compiler error. All right, so the type annotation is basically a colon after the variable name with the type. So if I change this like, oh, I thought name was an int, it's going to say that is not an int. I got a string instead. And I assume there's a float, right? My float is equal to 3.5. There we go. We'll turn this back to string. So here it's happy with a float, and I think if I type in float here, that's probably the right answer. But if I do int, it's not happy. And then what if I got rid of this? What if I just said 3? Is that a float? No. So if 3 literal is an integer, but if I do 3.0, then it's fine, it's a float. And for integers, 0b1111 is binary, right? So let's actually try printing this. And it probably will print it in decimal, I'm pretty sure. $15. Yeah. Oh, let's try 3 dot. Yeah, that's kind of interesting. Hey, good job, Eric. Thank you. Or 0.0. Yeah, 0.0 should work. Oh, crap. Look at that. It does not work. So if you really want a 0 as a floating point, you do 0.0 or you do 0 dot, right? Yeah, that works. Type annotations. Where are we on this now? Ah, we're here. Let's get through this and then we can call it a day. That's a good stopping point. Or maybe we just do like one function or two. All right, so we finished type annotation. Type imports. Other modules may also define types that we wish to refer to. In this case, we need to import them. Like functions, types can be referred to in a qualified way by putting the imported module name and a dot before the type name. You ever read something and then like you don't remember anything that you read? That just happened. Other modules may also define types that we wish to refer to. Okay, so we got some other module like Gleam/IO that can have types in it, and we need to import it. Like functions, type can be referred to in a qualified way. Yeah, so we can do like io dot the type name. Types can also be imported in an unqualified way by listing them in the import statement with the word type before the type name. Unlike functions, Gleam types are commonly imported in an unqualified way. I see, which means that unqualified sounds kind of worse, but in a way you still have to be very direct here and say like, I really want string tree. So what's going on here? There's byte tree dot byte tree. So this is the qualified way where I'm calling it specifically, and then we call new, and then we have those are bytes, and then we have text, which is a string tree, and we call string tree dot new here, and this is unqualified. So it's interesting here because here's the type name, right? So here's the variable name, colon, the type annotation, which we saw before. And here is the variable name, and here is the type annotation. Do you think we can rewrite this? Let's try it. It's really import Gleam byte tree, import Gleam, and that we had a string tree, and I know that we wanted to import the type here too. I don't remember the syntax exactly. It was something like dot type string tree. Was that it? Import byte tree. Yeah, that's probably not it, right? Well, let me try finish. It's very short, so let's see what happens. So then we made a let statement where we had like byte tree, and then we had like the type name, which was like, maybe it was all capitals. Maybe it was like, yeah, that's what it was. It was like byte tree. No? I'm expecting a lowercase name here. Maybe it was byte tree. Anyway, then we have byte tree. We have byte tree dot. God, this is complicated now. I don't remember. Equals byte tree dot new. It was something like this. So what am I getting confused about? We have the module name and then we have the type name. The type name, the module name was something like byte tree, and then the type name I don't remember. So I'm going to have to look back and try to remember the module name versus the type name. Okay, let's go back. The module name is bytes underscore tree, and the type name is capital bytes capital tree. And here there's just a dot and a type. So I was close there. Okay, let's try that again. Bytes, plural. So we go import Gleam slash bytes tree, import Gleam slash string tree, I think. And then here we do dot type string tree. The type name I remember had the capitals, right? And then we do let, I'll just call it BT. Now we give it the type annotation, which should be bytes tree dot bytes tree equals, I think it's bytes tree dot new. And then we let string tree is just string tree here because this is the unqualified annotation, equals string tree dot new. Is that right? Here, we'll put it over here. Oh, you guys don't see this. Ah, well. I copied and pasted it, so now if I reload this, we can see my code versus their code. So this was my code here, import bytes tree. That was the same. Import Gleam string tree. This was the same. And then here's my bytes tree. If I just change the name of the variable, the rest is the same. And here's my, if I just change the variable to, then it's the same. All right, we did it. So, you know, this is really good to just make sure that we actually learned it. So it makes sense. And notice, like, it's hard. Like, you think you understand it when you're actually like reading it, but then when you try to write it, at least for me, that's when like I get a little bit lost. Where is, oh, here it is. We don't need that, at least not for now. All right, next, type aliases. We're getting close. Type aliases blocks lists and constants. Type aliases. A type alias can be used to refer to a type by a different name. Giving a type an alias doesn't make a new type, it is still the same type. A type's name always starts with a capital letter, contrasting to variables and functions, which start with a lowercase letter. Yeah, we noticed that with int, float, bool, all of those had capital letters to start with. When the pub keyword is used to type alias is public and can be referred to by other modules. Oh, I read it wrong. When the pub keyword is used, the type alias is public and can be referred to by other modules. There should be like a comma here. Is used, comma, the type alias. That's why I didn't read it right. So where's the type alias? Here it is. It means the type alias is public and can be referred to by other modules. It kind of means like you're exporting it, like someone else can use it. So here's user ID. If I get rid of this, nothing changes because there's no other module calling us, right? So this whole pub thing doesn't really change anything. It's interesting how this is on a new line here. Like, I would have done this, but I guess this is the Gleam way of doing it. User ID is 1, 2, debug 1 equals 2. I see they're showing that's the same. Alright, let's try to just do this again then. So we say let x is, oh, we have our type pub. How do you alias it? Pub type? Pub type foo is equal to int. Is that right? And then I do let x foo is equal to 1. Let y int is equal to 1. And then I do io.debug x is equal to y. Okay, let x. I was not expecting this. Found the keyword let. Expected one of an import const type or I'm definitely this is wrong. Pub type. Can't remember how we did it. Is it here? When the word pub. Okay, let's just look. Let's just cheat. Pub type user ID is equal to int. What did I do? I can't remember now. You know, I hadn't even realized that, like, look, like some of these, yeah, all of these have a main and it didn't really like talk about it. That all of these have a main. Alright, so let's try it again. Import Gleam /io because we're going to need to /io, right? Yeah, because we're going to eventually need to do io.debug. And then I think it was like function main. Maybe like this, right? No? Anyway, now we have our type, which was called, you guys are seeing how embarrassing my memory is. Pub type foo is equal to int, right? And now we have let x foo is equal to 1. Let y int is equal to 1. And then we do io.debug x is equal to y. Private function. So I'm guessing I need to make this pub. There we go. True. Perfect. And I guess if I turn this to 2, obviously it will become false. The other thing is I bet I can get rid of this and type in gleam.io. Oh, you can't. You can't do that. You still you actually have to import it. All right, good to know. I think we figured this part out. Blocks. Blocks are one or more expressions grouped together with curly braces. Each expression is evaluated in order and the value of the last expression is returned. Any variables assigned within the block can only be used within the block. Okay, so we can make nested scopes basically. Try uncommenting io.debug degrees to see the compiler error from trying to use a variable that is not in scope. Blocks can also be used to change the order of evaluation of binary operator expressions. All right, we'll need star asterisk binds more tightly than plus, so the expression 1 plus 2 multiply 3 evaluates to 7 because the 2 and 3 binds first, which is 6, and then we do the plus. If the 1 and 2 should be evaluated first to make the expression evaluated to 9, so then it would be 3 times 3. So if we wrapped it in these curly braces, then it would run it first. So, but this is similar to grouping with parentheses in some other languages. All right, so change IO debug degrees. Okay, so what's happening here is we have degrees in here. And we're trying to use, but degrees is only in scope here. It only has meaning within this. So when we uncomment this, it says, I don't know degrees. But obviously if I move this in here, now it works, right? So 64, it prints 64. And then it goes over here, it calculates Celsius and prints out 17. In some of these languages like IO debug, well, yeah, I don't think this would work if I put this after degrees. Oh, it still does. Look at that. So IO debug will basically take in a parameter that it wants to print out, and it returns that also. So it's basically, we don't need this here, and it will still work. It still prints out 64. That's how Elixir works also. But if I change this to 3, then yeah, obviously now it changes to 3 here. How did this change? Celsius is 17. And now it changed because Fahrenheit is equal to this. I see it's using this value over here. So what's happening is Fahrenheit is being assigned whatever this evaluates to, and this thing evaluates to the last element in this scope, which is IO debug degrees, which returns degrees. And then Fahrenheit gets to be 64, and then we use it over here. That makes sense. Okay, I think we can move on. Lists. Lists are ordered collections of values. List is a generic type having a type parameter for the type of values it contains. A list of ints has the type list int, and a list of strings has the type list string. Okay, so we have a generic type, and it takes in a type parameter. So we have something like generics here. Maybe this is something that is something we can expand on ourselves, user definable. Lists are immutable, singly single linked lists, meaning they are very efficient to add and remove elements from the front of the list. Yeah, when you only have singly linked, it means all the links point in one direction. So you have basically a pointer to the first item. So it's easy to add something to the beginning. But if you want to add something to the very end, you have to traverse all those links. Counting the length of a list or getting elements from other positions in the list is expensive and rarely done. I do it all the time because I'm a bad programmer. It is rare to write algorithms that index into sequences in Gleam, but when they are written in a list, a list is not the right choice of data structure. Generally, I would agree, but sometimes, you just want to like get 3 elements at a time or something, so I guess it's a little bit like popping 3 elements from the top. I think that's okay. So let's see, how does this work? Lists are these kind of square brackets. And here, I see, this is the prepend operator. So it's saying add -1 and 0 to ints. All right. And so we print out 1, 2, 3 first here. That's this. We prepend this -1 and 0 to the 1, 2, 3, and it works. And then the original list has not been changed. This is something really key with these functional languages, is that like if you're manipulating the thing they're pointing to by like prepending or whatever, this thing never gets changed. This thing is always going to stay the same unless, of course, like you change it by like reassigning it here. All right, let. And now you can see int is different, right? But even if I did this here, then it doesn't change this prepended list. Well, of course it doesn't. Let's try to make sure we know how to do this. So I think I prefer to start with pub function main, and it takes angle brackets, right? And we can do io.debug hello just to make sure we know the syntax. Import gleam /io. There we go. So that works. And now we are going to make something. We're going to make a list. So we'll do like let. They called it int, so we'll call it ints, and it's 1, 2. Were there commas in the list? I don't think so, right? I think it's expecting commas. There you go. So it does need commas. And then I can do io.debug ints, and we print out the ints here. And now we're going to prepend the list. So here's a list where we're adding 10 and 9 into it, and then we do ... ints. That is not how you do it though, isn't it? Maybe it's just ... Wasn't it ... Huh. I'm gonna have to look because I just don't remember the thing. This is what I typed, isn't it? ... ints. Now I can't remember what I typed. This is why I should keep it all in a file. I thought this was exactly what I did. Alright, we can look in the video later. Let's do it again. Pub function main. import Gleam /io. Let ints is equal to 1, 2, 3. io.debug ints. Then we do io.debug. Here's a new list. 1, 2, comma, ints. Hey, now it worked. I must have forgotten like parentheses or something silly like that. I mean, I typed in like 10, 9 or something, didn't I? But now it works. All right. And then they printed out ints again to show that it wasn't changed. 1, 2, 3. And remember we had like that type thing. Let's try to add a type notation for this. It was like pub type, and we gave it my list type is equal to list int, right? That should be correct. And now I should be able to say my list. And that actually worked. So now if instead of 1, 2, 3, I said, hey, these are like floating point numbers. Here, let me get rid of this. .0. It's saying that it doesn't like the fact that these numbers aren't also floating point. All right, look at that. So funny enough, even though these are all floating point, when it debugs it, it prints it out as integers, right? But I think if I say my list here, it's going to fail because my list is supposed to be a list of integers, and it's saying it says I'm getting a list of floats. So if I change this to float now, everyone's happy again. But be aware that in Gleam, when you print out a list of numbers with debug, you can't tell if it's a list of integers or floats, which is kind of interesting. Could be like a debugging problem in the future, you know? All right, next. Constants. How much further? Oh, we're on the last one. Constants, as well as let assignments, Gleam also has constants which are defined at the top level of a module. Constants must be literal values. Functions cannot be used in their definitions. Constants may be useful for values that are used throughout your program, permitting them to be named and to ensure there are no differences in the definition between each use. Using a constant may be more efficient than creating the same value in multiple functions, though the exact performance characteristics will depend on the runtime and whether compiling to Erlang or JavaScript. All right, well, so it may not be faster, but if you want a constant, it could make your Satoru, I'm back, glad to help with something. What? Oh, you're back. Your name changed. Welcome back. Yeah, we're good. I think we're at the last section of this basic stuff. Then it goes into functions, then flow control, data types, standard library, advanced features. Wow, that's so what is this? Like 1, 2, 3, 4, 5, 6. So if we do one of these sections in a video, then like basically it'll be like 6 videos. Yeah, I don't think I'm going to continue after this because it's already an hour and a half. But let's finish constants. This will be available as a stream, or I'll probably cut it and make it into a little bit shorter video on YouTube. So if you missed anything, you can always go back. Don't worry. All right, so let's look at what constants look like. Lists. Const. So this is before the main function. We have const ints list da 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 floats da 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 da. This one has a type annotation and this one doesn't. And then we're just printing out the ints, which is 1, 2, 3, that they're the same. And then here we print out the floats. There we go. And we print if the floats are equal to the same. I changed my nickname to my Japanese name. Showing up with my full name doesn't sound super safe on streams. Oh, I'm so sorry. Yeah. I don't know how to I can't retroactively change that. You're going to be okay with that? So yeah, let's try to make sure we know how this is working. Oh, look, we have a sed user. La commande sed. There we go. Look at that beautiful sed stuff. Alright, so we were trying to remember how constants looked. Do they have a pub in front of it? Pub function main io.debug foo, and we have to import gleam/io, and there goes 1. I imagine I can do pub. This probably allows another module to use my foo. So we'll call it int list, which is a list of integers. No, let's make it like word list, right? We should be a little bit unique. And that is a list of strings. And this obviously it doesn't like word list. I think it needs to be yeah, here we have a problem because it says, hey, I thought you were going to give me a list of strings, but you gave me an integer, obviously. So let's make it a list of strings. Here is a list, right? Yeah, super fine for now, so no need to worry, but sometimes I participate. Yeah. I'm small fish, small fish. And then we wanted to compare it, right? So it was like, let's print out word list here. And you can see it printed out the list of strings. And then there was another thing they did where they were trying to check equality. Is word list equal to here? It's still false, you see. Is as soon as I type T here, T turned true. And I think they did another one, but we get the idea, right? That is, those are constants. So we covered all of the basics today. We'll do another stream where we cover functions and flow control. I don't know when I'm going to do it exactly. Let's just take a quick peek. Yeah, look, we're into functions. I like the way these parameters are passed and it looks cool. This is the return result. Isn't this very much like Rust? I don't use Rust enough to remember exactly, but it sure looks like it. So if you're watching this on YouTube and you enjoyed it, please do like and subscribe. There's a Discord server I mentioned earlier. It should be in the description. So if any of this was like, hey, I didn't really quite understand something, today I think was pretty easy. I don't really know what I would say. Maybe the qualified stuff was a little weird, but otherwise type annotations was pretty clear. The imports was pretty clear. I think it all makes sense. Yeah, it's very Rust-like, right? Me gusta. Um, and we'll continue, but I gotta go back to the other languages I look at first. But I'm just gonna do whichever one I feel like anyway. So thanks so much for joining me, and I will catch you all soon. Thanks. Thanks, Saturo. Bye.